Kevin Costner's Waterworld didn't do well at the box office, raking in just about $80 million from the more than double they spent to make the film at $172 million. The film went on to become a cult classic, and even though they spoke about an Earth completely submerged in water, a few exoplanets with this same characteristic exist, scattered all across the universe. We've come to know about their existence as far back as 20 years in the past, but with the jaw-dropping accuracy that the James Webb Telescope conducts its observations, we could get a closer look at another incredible water world. The only difference about this one is that Costner, his castmates, and crew would have to travel 100 light-years to reach their planet-wide set. What do we know about this planet made of water? And more importantly, does it have life? In a binary system located in the constellation of Draco, the Dragon, as seen from the northern sky on Earth, close to the Big Dipper lies TOI 1452b, a world that's filled to the brim with a liquid we humans cannot survive without. Charles Cadeau, a PhD student at the Université de Montréal, a member of the Institute for Research on Exoplanets, or IREX, has led a team of international researchers who have discovered TOI 1452b that orbits one of two small stars in its system of about 100 light-years from Earth. The exoplanet is larger in size and mass than Earth and is located at a distance from its star where it would not be too hot or cold for liquid water to exist on its surface. The astronomers think it could be an ocean planet, a planet covered by a thick layer of water, like some of Jupiter's and Saturn's moons. In an article published by the Astronomical Journal, Cadeau and his team describe the observations that they made about this unique exoplanet. René Doyon, Université de Montréal professor and director of IREX of the Observatoire du Mont Mégantic, or OMM, said, "I'm extremely proud of this discovery because it shows the high caliber of our researchers and instrumentation. It is thanks to the OMM, a special instrument designed in our labs called Spiro, and an innovative analytic method developed by our research team that we were able to detect this one-of-a-kind exoplanet." The researchers found this exoplanet with help from NASA's space telescope TESS, which searches the entire sky for planetary systems like our own. The TESS signal showed a slight decrease in brightness every 11 days, which led to the prediction of a planet 70% larger than Earth. Astronomers like Charles Cadeau do follow-up observations of candidates identified by TESS to confirm their planet type and characteristics. Cadeau used PESTO, a camera that was developed by Université de Montréal professor David Lafreniere and his PhD student François-René Lachapelle. Cadeau explains, "The OMM played a crucial role in confirming the nature of this signal and estimating the planet's radius. This was no routine check. We had to make sure the signal detected by TESS was caused by an exoplanet circling TOI 1452, the largest of the two stars in that binary system." As we mentioned before, TOI 1452b lies in a binary star system, meaning the system has two stars. Our Sun is larger than the host star TOI 1452, which is one of the two stars of similar size in that system. The two stars orbit each other and are very close to each other at 97 astronomical units, which is about 2.5 times the distance between the Sun and Pluto. 1 astronomical unit is the distance between the Earth and the Sun, which is about 92.9 million miles. The TESS telescope sees them as a single point of light, but PESTO's resolution is high enough to tell that the exoplanet orbits TOI 1452. This was confirmed by later observations by a Japanese team. To determine the planet's mass, the researchers then observed the system with Spiro, an instrument installed on the Canada-France-Hawaii telescope in Hawaii. Spiro is a near-infrared spectropolarimeter optimized for high-precision radial velocity measurements. Spiro was mostly designed in Canada and is best for studying low-mass stars like TOI 1452 because it works in the infrared spectrum, where these stars are the brightest. Even then, it took over 50 hours of observation to figure out how heavy the planet is. It is thought to be nearly 5 times the mass of Earth. Researchers Etienne Artegau and Neil Cook, who work at IREX at the Université de Montréal, play a big part in figuring out the data. They created a method that can find the planet with spiro data. Artegau explains, the line-by-line method allows us to clear the data obtained with spiro of many parasite signals, and to reveal the weak signature of planets, such as the one discovered by our team. The team also includes Farbar Jahandar and Thomas Vandal, two PhD students at the Université de Montréal. Jahandar looked at the host star's composition, which helps figure out the planet's internal structure, while Vandal worked on analyzing the spiro data. The exoplanet TOI 1452b is probably rocky like Earth, but its size, mass, and density are very different from Earth. Earth is a very dry planet, even though we sometimes call it the blue planet because about 70% of its surface is covered by ocean. Water only makes up a small part of its mass, less than 1%. Some exoplanets may have more water than we know. In fact, the last few years, astronomers have found and figured out the size and mass of many exoplanets that are about 3 times bigger than Earth. Some of these planets have a density that can only be explained if a large part of their mass is made up of lighter materials than those that make up the internal structure of the Earth, such as water. These hypothetical worlds have been dubbed ocean planets. Kadiao further explains, TOI 1452b is one of the best candidates for an ocean planet that we have found to date. Its radius and mass suggests a much lower density than what one would expect for a planet that is basically made up of metal and rock like Earth. The University of Toronto's Mikhailo Plotnikov and Diana Valencia are specialists in exoplanet interior molding. Their analysis of TOI 1452b shows that water may make up as much as 30% of its mass, a percentage similar to that of some natural satellites in our solar system, such as Jupiter's moons Ganymede and Callisto, and Saturn's moons Titan and Enceladus. An exoplanet such as TOI 1452b is a perfect candidate for further observation with the James Webb Space Telescope. It's one of the few known planets that have characteristics similar to an ocean planet. It is close enough to Earth that researchers can hope to study its atmosphere and test this hypothesis. It is located in a region of the sky that the telescope can observe year-round, which will make observations simpler. Duyon, who overviewed the conception of James Webb's component NIRIS, or Near-Infrared Imager and Slitless Spectrograph, said, "Our observations with the Webb telescope will be essential to better understanding TOI 1452b. As soon as we can, we will book time on Webb to observe this strange and wonderful world." Even if the calculations were wrong and TOI 1452b isn't an ocean planet, it's still a good target for study because its radius is between those of super-Earth and sub-Neptune planets. Planets in that range have been found so rarely it's been dubbed the radius gap, and TOI 1452b is right in the middle of it. And since where it's located makes it simpler to observe, we may soon know more about this elusive type of exoplanet. As for the ever-curious question, does it have life? We won't know until we find out more. Until then, let's rewatch the movie Waterworld and imagine it to be the same. Well, sort of. Don't do that. Just think about the possibilities we could find on this marvelous exoplanet. So, what are your thoughts? Is TOI 1452b a complete water world? Or is it similar to Earth? Will we be able to find life on this planet? And what more will the JWST find in this distant world? Let us know in the comments below, and as always, thanks for watching Space Traveler.